Welcome to the fourth video of the module 3. In this video I am going to discuss various possible solution of heat equation. So what are the various possible solutions of the one-dimensional heat equation, that is ut is equal to c square uxx by method of separation of variables. Let us consider the heat equation, that is dou u by dou t is equal to c square into dou square u by dou x square. Let u is equal to xt be the solution of the given PDE. Then dou by dou t of xt is equal to c square into dou square by dou x square of xt. That is, taking the x out, x into dt by dt is equal to c square t of d square x by dx square. Let us divide throughout by xc square t. Then we get 1 upon c square t into dt by dt is equal to 1 by x into d square x by dx square. Let us call this as k. Now 1 by c square t into dt by dt is equal to k, or 1 by x into d square x by dx square is equal to k. Cross multiplying and taking it to one side, we get dt by dt minus c square kt is equal to 0. Another equation is d square x by dx square minus kx is equal to 0. Putting it in the d operator form, we get d minus c square k of t is equal to 0 and d square minus k of x is equal to 0. Case 1. Put k is equal to 0. Then we get d of t is equal to 0 and d square of x is equal to 0. Replacing m by the d, then we get m into t is equal to 0 and m square into x is equal to 0, which gives m is equal to 0 and m square is equal to 0, giving the solution as t of t is c1 and x of x as c2 plus c3 of x. And therefore, the solution u is equal to c1 into c2 plus c3 of x. Case 2. When k is equal to p square, that is positive, we get d minus c square p square of t is equal to 0 and d square minus p square of k is equal to x is equal to 0. Replacing d with m again, m square minus c square p square of t is 0 and d square minus p square, m square minus p square of x is equal to 0. That is, m minus c square p square is equal to 0 and m square is equal to p square, or m is equal to c square p square and m is equal to plus or minus p. So t of t is equal to c4 into e power c square p square of t and x of x is equal to c5 e power pt plus px plus c6 e power minus px. So u is equal to c4 into e power c square p square t into c5 e power px plus c6 e power minus px. Case 3. When k is a minus p square, that is negative, d plus c square p square of t is 0 and d square plus p square of x is 0, or m plus c square p square of t is 0 and m square plus p square of x is 0. That is, m plus c square p square is 0 and m square plus p square is 0. M is minus c square p square and m is minus p square. Therefore, t of t is c7 e to the power of minus c square p square t and x of x is c8 cos px plus c9 sin px. Hence, u will be equal to c7 of e to the power of minus c square p square t into c8 of cos px plus c9 of sin px. That gives the solution. Thank you.